I want you to picture something that doesn't feel real at first, because your intuition was never built to handle distances like this. Right now, as you sit here, there is a human-made object so far from Earth that a signal traveling at the speed of light, the fastest thing the universe allows, takes more than 23 hours just to reach it, which means that when engineers send a command, they must wait nearly a full day before even knowing whether the machine heard them. And yet what makes this stranger is that nothing is pushing it anymore. No engine firing, no steering, no correction. Just a silent piece of hardware drifting forward through darkness. And despite that passivity, it will outlast every skyscraper, every language, every nation, and possibly even the surface of the planet that built it. You and I are used to thinking in terms of effort and motion. We imagine that if something goes far, it must keep accelerating, must burn fuel, must fight resistance. But space does not work that way. And the first time I really understood this, I remember staring at a chalkboard covered in arrows representing forces and realizing there weren't nothing to slow the thing down, nothing to push back, just inertia, carrying it onward like a puck sliding forever across a perfectly frictionless table. Except the table is the galaxy, and the puck is something built by human hands in the late 20th century. We launched Voyager 1-inch 1977, and at the time nobody thought of it as a cosmic messenger meant to wander the interstellar dark. It was built to study Jupiter and Saturn, a grand tour mission designed to take advantage of a rare planetary alignment, and like many engineering projects, it was expected to finish its job, send back data, and then fade into silence. Another successful experiment archived in history, but something unexpected happened. Not dramatic, not explosive, just the quiet continuation of motion. Because once the gravity assists were complete and the probe had been flung outward, there was nothing left to stop it. And it simply kept going and going and going until decades passed, and the small machine that had once skimmed past swirling gas giants became the farthest object humanity has ever created. It weighs less than a compact car. Its computer is laughably primitive by modern standards. And if you placed it next to your phone, you might assume the phone was the more sophisticated device, yet that small machine is now roughly 24 billion kilometers away. A number so large that your brain tries to compress it into abstraction. So let me pull it back into something physical, because numbers alone don't help. Imagine Earth shrunk to the size of a basketball, sitting in a field, the sun placed about 30 meters away like a glowing lamp at the edge of a driveway. And then you walk a full kilometer before you place Voyager, and only then, only after that walk, do you realize the nearest star would still be thousands of kilometers beyond that, farther than entire countries. And suddenly the distance Voyager has traveled feels both enormous and heartbreakingly small at the same time. The probe is moving at about 61,000 kilometers per hour, which sounds absurdly fast to you because it is faster than any aircraft, faster than any bullet, faster than anything you could ever personally experience. Yet space is indifferent to what impresses us. And at that speed, the probe would take roughly 75,000 years to reach even the nearest star, not because it is slow, but because the universe is vast in a way that makes speed itself almost irrelevant. 75,000 years ago, modern humans were still spreading across continents. The earliest art had barely begun. And if you project forward that same span of time again and again, civilizations would rise and collapse. Coastlines would shift. Ice ages would come and go. And Voyager would still be in transit, gliding forward without awareness, without intention, without urgency, just obeying the simplest law in physics. An object in motion stays in motion. When you let that sink in, something subtle happens, because the journey stops feeling like a mission and starts feeling like a statement about scale. And you realize that the most distant thing we have ever built has barely begun to leave our neighborhood, which means the universe is not just big. It is big in a way that quietly reshapes how you think about exploration, distance, and what it really means for something built on a small world to reach outward into the dark. If you look closely at Voyager 1, the strangest thing about it is not how far it has traveled, but what we chose to put on it, because bolted to the side of a machine designed for planetary measurements is something that has no scientific function at all. A gold-plated record carrying sounds and images from Earth, and that decision tells you more about human beings than the trajectory ever could. We did not send only mathematics, even though mathematics would have been the most universal language. And we did not send only engineering diagrams, even though those might have been the most practical. Instead, we sent music, greetings, footsteps, vent, laughter, and the sound of a newborn child, which means that when we had one chance to place something into interstellar space, we did not introduce ourselves as a technical civilization first. We introduced ourselves as a living one. I want you to imagine the moment this idea becomes real, not as an abstract symbol, but as a physical object, technicians holding a polished disc, carefully attaching it to a spacecraft that will never return, knowing that once the rocket leaves Earth, there is no editing, no revision, no second attempt, just one frozen snapshot of humanity carried outward indefinitely. And that gives the whole gesture a kind of quiet boldness, because the people who made that decision understood the odds. They knew the probe would most likely never be found, never decoded, never even seen. Yet they included the record anyway, which is a very human move, not entirely rational, not entirely practical, but deeply revealing. It reminds me of the way you sometimes write your name in wet cement, not because you expect anyone to read it centuries later, but because the act itself acknowledges that you were there, that at one moment in time you existed and chose to leave a trace. The contents themselves are almost disarmingly simple. Greetings in multiple languages, classical music, folk songs, natural sounds, and images encoded as analog signals, along with instructions etched into the cover showing how to play the record, how to interpret the timing, how to reconstruct the images. And there is something wonderfully careful about that, because whoever designed it assumed that whoever might find it would know nothing about us. Not our units, not our biology, not even our senses. So the instructions begin with fundamental constants and simple diagrams, building upward, step by step, like teaching physics to someone who has never seen Earth. The humility in that approach stands out because we are not declaring superiority or broadcasting power. We are trying to be understandable, and that is a very different instinct. What fascinates me most is how fragile the whole idea is compared to the scale of the journey, because Voyager 1 is traveling through a region where distances are measured in light years, yet the message it carries is analog, physical, vulnerable to micrometeoroids, radiation, and time, and still we trusted that a simple metal disk could survive long enough to represent us. There is no redundancy, no backup copy traveling alongside it, just one record, one set of sounds, one collection of images, and that limitation forces the message to feel personal rather than institutional. As if instead of sending a library, we sent a postcard. When you think about it that way, The golden record stops being a technological curiosity and becomes something quieter. A deliberate choice to compress a civilization into a few minutes of audio and a handful of images, not because that is sufficient, but because it is all we could carry. The problem with interstellar distance is not that it is large, but that your intuition quietly collapses when you try to hold it. Because everything you have ever experienced trains you to think that far means hours, maybe days, occasionally months. Yet space introduces a kind of separation so extreme that even the fastest speeds, begin to feel almost stationary. Voyager 1 is roughly 24 billion kilometers from Earth. And that number sounds impressive until you notice how quickly your mind turns it into a blur. So the only way to understand it is to shrink the solar system into something you can walk through. Imagine placing Earth on the ground as a basketball, then pacing about 30 meters away and setting down a bright lamp to represent the sun. And already you feel the emptiness because nothing exists between those 2 points except air. But the real surprise comes when you try to place Voyager 1 because you have to keep walking far past the sun, far beyond what feels reasonable, until you are about a kilometer away from the basketball. And only then do you stop and realize that the nearest star would not be somewhere across the field or even across the city, but thousands of kilometers beyond you, farther than entire countries. And suddenly the distance Voyager has covered begins to look less like a triumph and more like a first cautious step. This is where human intuition fails most dramatically, because we instinctively assume that once you leave the planets, the next destination should not be that far away, as though stars were arranged like islands in a sea, each separated by manageable stretches of space. But the reality is closer to a few grains of dust scattered across a continent, and Voyager is still drifting away from the first grain. The probe is moving at about 61,000 kilometers per hour, which is fast enough to circle Earth in under an hour, fast enough to cross entire continents in minutes. And yet at that speed it would take roughly 75,000 years to reach Proxima Centauri, the nearest star to our sun. 75,000 years is not a number that behaves like time anymore, because when you compare it to human history, you realize that when Voyager would finally arrive, everything familiar to us would belong to a distant archaeological layer. Languages transformed beyond recognition, coastlines reshaped, cities buried, and the machine would still be gliding forward with the same quiet momentum it has today. There is something almost unsettling about that, because we like to think of space travel as a journey from one place to another, but the distances between stars are so large that the idea of travel itself begins to blur into drift. And the distinction matters. A journey implies intention, milestones, a destination that feels reachable, whereas Voyager's motion feels more like being carried by physics alone. A small object sliding through an environment so empty that nothing meaningfully interrupts it. If you could sit beside it, you would see no landmarks, no passing worlds, no shifting scenery. Just a slow change in the background of distant stars over tens of thousands of years, which is not something the human mind evolved to process. We are comfortable navigating forests, oceans, even continents. But interstellar space removes all reference points, leaving only distance layered upon distance. The deeper implication is that speed, which dominates human engineering, becomes secondary. Once you enter this scale, even if Voyager were moving 10 times faster, the trip to the nearest star would still exceed the span of civilizations. And even if it were 100 times faster, you would still be talking about time measured in millennia. This is why the probe's current position, though record-breaking, barely scratches the surface of interstellar space. Because the region between stars is not something you cross quickly. It is something you inhabit for ages. When you finally absorb that, the number 24 billion kilometers stops sounding like the edge of anything and starts sounding like the beginning of a much larger emptiness. And Voyager, on drifting outward at a speed that once seemed extraordinary, becomes less a traveler between worlds and more a marker showing how far human intuition can stretch before it quietly gives way to the true scale of the universe. To understand what Voyager 1 is moving through now, you have to let go of the idea that the solar system ends somewhere near the planets. Because the sun does not simply illuminate space, it continuously exhales it, sending a stream of charged particles outward in every direction. A plasma wind that expands for billions of kilometers and forms a vast bubble around our star. And inside that bubble, everything is still, in a subtle sense, part of the sun's environment. This region is called the heliosphere, and you can think of it as the sun's atmosphere stretched across interplanetary space, a protective envelope that deflects a portion of the high-energy radiation coming from the rest of the galaxy. The planets orbit deep inside this bubble, and for most of human history we assumed the solar system simply faded into the dark beyond them. But in reality there is a boundary, not a wall, not a sharp line, but a gradual transition where the sun's influence weakens and the interstellar medium begins to dominate. That boundary is the heliopause. And in 2012, Voyager 1 crossed it. The crossing was not dramatic in the cinematic sense. There was no flash, no sudden darkness, no visible threshold. Because space does not provide markers the way land does. But the instruments aboard the probe detected something unmistakable. The density of charged particles changed, the magnetic field shifted direction, and cosmic rays originating from outside the solar system became noticeably stronger, as if Voyager had stepped out from behind a shield and into a colder, more exposed environment. I like to imagine this moment the way you might step away from a campfire at night, where the warmth fades gradually, the sounds of the fire soften, and the surrounding cold becomes more noticeable. Not because the universe changed, but because you left the small region where your local source of heat dominated everything. The heliosphere is that campfire, and Voyager 1 is now far enough away that the rest of the galaxy begins to assert itself. What makes this transition remarkable is not just that we crossed a boundary, but that we confirmed something profound about our place in space. Because for the first time, a human-built object was no longer moving through a region shaped primarily by our own star. Inside the heliosphere, even the emptiness is still part of a solar neighborhood, particles streaming outward from the sun. Magnetic fields carried along with the solar wind, a kind of extended solar environment, but beyond the heliopause, the probe enters a medium shaped by distant stars, ancient supernovae, and the diffuse gas that fills the Milky Way. The change is subtle, but conceptually enormous, because Voyager 1 is no longer just traveling far from Earth, it is traveling through matter that did not originate here, drifting in a region that belongs not to our solar system, but to the galaxy as a whole. And yet, what it finds there is not a crowded cosmic sea, but something even more surprising: extraordinary emptiness. The interstellar medium is not packed with debris, not filled with dense clouds, but composed of incredibly thin wisps of gas, often just a few atoms per cubic centimeter, a vacuum so extreme that collisions are rare events separated by vast distances. If you were somehow traveling alongside Voyager, you would see nothing change visually. No stars rushing past, no particles streaking by. just darkness punctuated by distant points of light, and the probe would continue forward without resistance, carried by inertia alone. The phrase silent ocean is not poetic exaggeration, it is physically accurate, because this region has almost no structure at human scales. No landmarks, no surfaces, only gradual variations in density and magnetic fields, detectable only by instruments. What fascinates me about this moment is how understated it is, because humanity left the sun's protective bubble without ceremony, without crowds watching, without even a visible event. And yet it marked the first time something we built truly entered interstellar space. Voyager 1 did not cross into a new territory in the way explorers once crossed oceans. It simply drifted across an invisible transition, and the significance lies entirely in understanding what that transition means. From that point onward, the probe is no longer a visitor to the outer solar system, but a traveler in the wider galaxy, moving through an environment that has existed long before the sun formed and will remain long after it fades. Most people imagine the solar system as something that ends somewhere beyond the last planet, as though Neptune marks the shoreline and everything after that belongs to the stars. But the sun does not stop at the planets. It continuously pushes outward, blowing a stream of charged particles in all directions. A solar wind that expands into space and creates an enormous bubble around our star. Inside that bubble, everything is still influenced by the sun, not just through gravity, but through plasma, magnetic fields, and radiation. And this region extends far beyond Pluto, far beyond the Kuiper Belt, stretching billions of kilometers into what looks like empty space. If you could see it, the solar system would not look like a set of orbits around a star. It would look like a vast glowing sphere drifting through the galaxy, carrying the planets inside it like dust trapped in a moving atmosphere. That bubble is called the heliosphere, and for decades it existed more as a theoretical boundary than a place we had actually touched. Voyager 1 spent years moving toward that invisible edge without any dramatic sign that it was getting close, because there are no markers in deep space, no change in color, no sudden drop in light, just a slow thinning of the sun's influence. Then, in 2012, something subtle but unmistakable appeared in the data. The density of charged particles coming from the sun decreased, the background of cosmic rays increased, and the magnetic field changed orientation, not abruptly, but enough to show that the probe had entered a region shaped by something larger than our star. It is a strange moment to think about, because nothing visible happened, yet physically everything changed. Voyager had crossed the heliopause, the boundary where the solar wind no longer dominates and interstellar space begins. I like to think of it as walking away from a small island into open ocean at night, where the land does not end with a cliff but fades gradually. The waves becoming deeper, the air colder, and the sense of isolation growing, not because you crossed a line you could see, but because the familiar influence behind you weakens. Inside the heliosphere, even the emptiness still belongs to the sun. Particles streaming outward, magnetic fields carried along, a kind of extended solar environment. But beyond that boundary, the probe moves through matter shaped by ancient stellar explosions, drifting clouds of interstellar gas, and magnetic fields threaded through the Milky Way itself. The change is measured in tiny differences, a few particles more here, a subtle shift in field direction there, yet conceptually it is enormous, because for the first time, a human-made object was no longer traveling inside the sun's domain. What makes this even more striking is what Voyager did not find. Science fiction often imagines interstellar space as crowded with debris, wandering asteroids, or dense clouds, But the region beyond the heliopause is astonishingly empty. So empty that the probe can move for years without encountering anything resembling an obstacle. The interstellar medium contains only thin wisps of gas, often just a few atoms in a volume larger than a room, which means Voyager is not navigating through a landscape, but drifting through an almost perfect vacuum. If you were riding beside it, there would be no sensation of crossing into a new realm, only the quiet knowledge that the sun's protective bubble is now behind you and the rest of the galaxy lies ahead in all directions. This is why the crossing of the heliopause matters more than it appears, because it marks the point where humanity's reach extended beyond the environment created by our own star. Voyager 1 did not arrive at another system, did not encounter a planet, did not even change speed. Yet it entered a region that belongs to the broader Milky Way. And from that moment forward, the probe has been moving through space. That was never part of the solar system at all. Carried silently through a vast medium shaped by stars we have never seen up close. When you imagine Voyager 1 moving outward, it is tempting to think of it as heading toward something fixed, as though the stars were nailed to the sky and the probe were slowly closing the gap. But the deeper reality is far stranger, because nothing in the galaxy is standing still. The sun itself is orbiting the center of the Milky Way at roughly 220 kilometers per second, carrying Earth, the planets, and everything we have ever known along with it. And the nearby stars are doing the same, each following its own path through a gravitational dance that unfolds over millions of years. That means Voyager is not traveling toward a static destination. It is drifting through a moving environment where the future neighborhood will not resemble the one we see today. If you could fast forward the sky by tens of thousands of years, the constellations would distort, familiar patterns would dissolve, and new stars would slide into view. Not because Voyager changed course, but because the galaxy itself never holds still. This is where time becomes as important as distance, because once you start thinking in spans of tens of thousands of years, motion accumulates in unexpected ways. Voyager 1 is traveling at about 61,000 kilometers per hour, which sounds decisive on human scales. Yet over 47,000 years, that steady drift becomes something meaningful. Astronomers have calculated that in roughly that amount of time, the probe will pass within about 1/6 light years of a small dim star called Gliese 445, located in the constellation Camelopardalis. The word pass can be misleading because there will be no close encounter in the way spacecraft pass planets. No dramatic flyby. No images of alien world. Just a distant approach, still separated by nearly 15 trillion kilometers. A distance so large that even light takes more than a year to cross it. And yet, in the context of interstellar space, that counts as coming near another star. I find that detail oddly compelling, because it transforms Voyager's journey from abstract drift into something with a faint sense of milestone. Not an arrival, but the closest thing to one that physics allows at this scale. Imagine a machine built in the 1970s, assembled with analog electronics and modest computing power, traveling autonomously for longer than recorded human history. Then passing through the outskirts of another stellar system long after every person involved in its creation has vanished. Civilizations will rise, languages will evolve, coastlines will shift, and that small probe will still be moving. Unaware of the passage of time, its trajectory determined decades earlier by gravity assists and inertia, there is something almost quiet about that persistence, because Voyager is not adjusting course, not aiming, not correcting, just continuing along a path that happens to intersect the slow motion of another star. The deeper implication is that encounters in interstellar space are governed less by intention and more by geometry. Stars wander, trajectories intersect, and over long enough time scales, even a simple outward drift becomes a journey through a changing stellar landscape. In 1,000,000 years, the sun itself will have moved far from its current position. And Voyager will no longer be heading away from the sky we recognize today, but from a completely different arrangement of stars. The probe will pass through regions that, from Earth's present perspective, seem empty. Yet over deep time, those regions fill and empty as stars migrate, like currents shifting in a vast cosmic ocean. This means Voyager's path is not just a line through space, but a line through a galaxy in motion, where the meaning of near and far changes slowly as everything drifts. What makes this difficult to absorb is that the scale of time removes any sense of urgency. 47,000 years is longer than agriculture, longer than cities, longer than written language, and during that entire span, Voyager will simply continue forward, its speed unchanged, its environment almost perfectly silent. The idea that its first approach to another star happens on that time scale reshapes how you think about interstellar travel, because it reveals that the galaxy is not something you cross quickly, but something you inhabit gradually, with encounters measured not in missions but in epochs. Voyager's future path is less a voyage between destinations and more a slow immersion in a moving stellar neighborhood, where even a distant pass counts as an event only because everything else is so widely separated. If you extend Voyager 1's journey forward, not by decades or centuries, but by a full 1,000,000 years, something surprising happens. Not because the probe suddenly reaches a new frontier, but because even after that immense span of time, it is still deeply embedded inside our own galaxy. 1,000,000 years sounds like an unimaginable duration, longer than all of recorded human history, multiplied many times over, long enough for species to evolve, climates to transform, and continents to shift. Yet in terms of galactic scale, it is barely a moment. During that time, Voyager will continue drifting outward at roughly the same speed, covering distance steadily but not dramatically. And astronomers estimate that after 1,000,000 years, it will be somewhere between 40 and 50 light years from Earth, far beyond anything we have ever reached, yet still surrounded by stars belonging unmistakably to the Milky Way. To understand why that matters, you have to compare that distance to the size of the galaxy itself. The Milky Way is about 100,000 light years across a rotating disk of stars, gas, and dark matter, so vast that even light takes 100 millennia to travel from one side to the other. Against that scale, 50 light years is almost nothing. A tiny displacement within a much larger structure, like walking a few steps inside a continent and still being surrounded by the same landmass in every direction. Voyager's 1,000,000-year journey would not carry it out of the galaxy, nor even close to its edge. It would simply move the probe into a slightly different stellar neighborhood, where the background of stars looks unfamiliar but still belongs to the same sprawling system. The constellations, if you could see them from Voyager's future position, would be completely unrecognizable, not because the galaxy changed, but because perspective shifted. Nearby stars rearranging into new patterns, while distant ones remain fixed in a slow-moving backdrop. What makes this particularly striking is how small that motion appears once you adopt a galactic viewpoint. The Sun itself is orbiting the center of the Milky Way at hundreds of kilometers per second, completing one orbit roughly every 230 million years, which means that in 1,000,000 years the solar system will have moved along its own path while Voyager drifts outward on a slightly different trajectory. The result is not a straight line away from Earth, but a subtle separation within a rotating disk. Both the probe and the sun, carried by the same gravitational structure, if you tried to draw this motion, it would not look like a dramatic escape, but more like 2 points, slowly drifting apart while both follow a larger circular path around the galactic center. The galaxy itself remains the dominant environment, and Voyager never leaves it, even on time scales that feel geologically immense. This perspective also reshapes how you think about the phrase deep space, because even after 1,000,000 years, Voyager is not in some empty void between galaxies, but still surrounded by hundreds of billions of stars, embedded in the same cosmic architecture that contains Earth. The probe would pass through regions of slightly different stellar density, perhaps drifting closer to some stars and farther from others, yet always remaining inside the Milky Way's gravitational embrace. If Earth still existed, it would appear as an unremarkable star among many, impossible to distinguish without precise measurements, and the sun would no longer dominate the sky, reduced to just another point of light. The journey does not end in isolation, but in anonymity, the probe becoming part of the general stellar population rather than something tied to a specific origin. The idea that 1,000,000 years of motion produces only this modest displacement forces a different understanding of scale, because it shows that galaxies are not merely large collections of stars, but structures so vast that even geological time barely moves you within them. Voyager, our most distant machine, would still be inside the Milky Way, still orbiting the galaxy, along with countless stars, still far from any boundary that might feel like an exit. The probe's trajectory, extended across 1,000,000 years, does not lead to another galaxy or even the outskirts of this one, but simply carries it deeper into the same immense system, revealing that what we call far is often just the beginning of a much larger environment. The most unsettling part of Voyager 1's journey is not how far it travels, but how long it will continue. Because unlike spacecraft that rely on propulsion, Voyager is simply coasting, and in the near-perfect vacuum of interstellar space, there is almost nothing to slow it down. No atmospheric drag, no meaningful friction, only rare collisions with microscopic particles separated by enormous distances, which means that once the probe was set on its trajectory, it effectively began a motion that could last for billions of years, long after its instruments fail, long after the power from its radioisotope generators fades, and the last whisper of radio signal disappears. The hardware itself will keep drifting, carrying its silent cargo through the galaxy. This creates a strange inversion of how we normally think about technology, because most machines are temporary, built to function briefly and then decay. Yet Voyager 1 is the opposite. A machine whose usefulness will end quickly while its existence continues almost indefinitely. If you project far enough into the future, beyond 1,000,000 years, beyond even the stability of Earth's environment, the contrast becomes sharper. In roughly 5 billion years, the sun will expand into a red giant, swelling outward and likely engulfing Mercury and Venus, possibly even reaching Earth's orbit, transforming the inner solar system into a hostile region of intense heat and radiation. Whatever remains of Earth's surface, whether vaporized or stripped to a barren core, will no longer resemble the world that launched Voyager. Cities will be gone, oceans gone, the biosphere erased, yet the probe will still be out there, far beyond the reach of that transformation continuing its quiet drift, it is an odd thought that something assembled in clean rooms with 20th century tools might outlast mountains, continents, and ecosystems, not because it is indestructible, but because it was placed in an environment where destruction is rare over even longer time scales. The galaxy itself evolves, stars form and die, clusters disperse, and gravitational interactions slowly rearrange the stellar population. Voyager will not witness these events in any conscious sense, but it will pass through their aftermath, moving through regions shaped by supernova remnants, diffuse gas clouds, and shifting stellar neighborhoods. The probe may wander for hundreds of millions of years without coming close to anything substantial, then drift past distant stars that were not even near its path when it was launched. Each encounter would be separated by immense spans of time, making the journey less like a sequence of destinations and more like a continuous glide through a changing environment. The golden record attached to its side would remain intact for a long time, protected by vacuum and low temperatures, a physical artifact carrying music, greetings, and images from a world that may no longer exist anywhere. At some point, the radio transmissions will stop entirely. The power supply is already fading, instruments being shut down one by one to conserve energy. And eventually there will be no electricity left to generate a signal. From that moment forward, Voyager becomes completely silent, indistinguishable from any other small object drifting through interstellar space except for the message attached to it. If another civilization were ever to intercept it, they would not detect a beacon or broadcast, only a quiet piece of hardware moving through the dark. They would have to notice it by chance, retrieve it, and decipher the instructions etched onto the record, reconstructing images and sounds from a species that existed millions of years earlier. The probability is extremely small, yet not zero, and that thin possibility is enough to give the probe a different kind of significance, because in the end, Voyager 1 is less a mission than a gesture extended across time. A physical statement that a technological civilization once existed around an ordinary star and chose to send a trace of itself outward. The machine will continue drifting long after the context that created it has vanished, carrying evidence not of power or expansion, but of curiosity, somewhere in the Milky Way, far in the future. It may pass unnoticed forever, or it may be discovered by beings who never knew Earth existed. The trajectory does not guarantee an answer. Only the persistence of the question embedded in that small record, whether anyone, at any time, will encounter a silent object and realize that it was built by minds that once looked into the darkness and decided to reach beyond their own world,